A matrix is a rectangular array of numbers. So we have three matrices here. When we talk about matrices, one thing that it's nice to know is how big is it? So we want to be able to say the size. The way we say the size of a matrix, we say the number of rows first, and then the number of columns. That looks like multiplication, but it isn't. We're going to read that rows by columns, like a 3 by 5 card, rows by columns. So matrix A here has 2 rows, 4, 1 on top, -2, -3 on the bottom. So 2 rows by also has 2 columns. Column 1 is 4, -2. Column 2 is 1, -3. So A is 2 by 2. Matrix B also has 2 rows, but it has 3 columns going up and down. Rows go across, columns go up and down. So B is 2 by 3. C is the same size as A, so we'll say C is also 2 by 2, size of a matrix. It's also useful to be able to talk about particular elements of a matrix. The way we're going to do that is by naming the row that it's in and then the column that it's in. Rows are always first, all the time, every time. The way we write that, I'm going to write lowercase the name of the matrix, so if I'm talking about matrix A, and then as a subscript, I'm going to put the row and then the column. So Aij means the element in matrix A in row I and column J. In particular, if I say A11, I'm talking about matrix A. I'm going to fight this thing to have that be lowercase, and it's not going to like that. It's going to change it again. That's okay. Matrix A, row 1, column 1. It's not A11, even though it looks like an 11. It's not. That's row 1, column 1. A11 is matrix A, first row, first column. There's a 4 there. So A11 is 4. If I say B23, I'm talking about the element of matrix B that's in the second row and the third column. B23, the thing that's there is a 0. So B23 is 0. If I say C23, I'm going to go to matrix C, the second row, the bottom row, the third column. C doesn't have a third column. There is no such thing. I could talk about C21, say. That's row 2, column 1. It does have that. In row 2, column 1, there's a 4 in matrix C. But C23, there's no third column, so there's no C23. We can do operations with matrices. Let's talk addition and subtraction. In order to add or subtract two matrices, they have to be the same size. So I can do A plus C, but I can't do A plus B because they're not the same size. Let's do A plus C. The way we're going to add two matrices is by adding corresponding entries. So I'm going to add A11 to C11, A12 to C12, and so on throughout the entire matrix. So the result is the same size as the two components. I know I'm going to need a 2 by 2 matrix here. I'm going to set that up because because the result is the same size as the components. Here we go. A11 is 4. C11 is negative 7. 4 plus negative 7, that's negative 3. Now we move to the 2-1. 1 plus 12. Sorry, that was the 1-2 entry. 1 plus 12. Here's the 2-1. Negative 2 plus 4 is positive 2. And the 2-2 entry, negative 3 plus negative 5 is negative 8. We can also do scalar multiplication. That means multiplying a matrix by a number. And the way we're going to do that is think of it as a giant distributive property. We're going to multiply each and every entry in the matrix by the same number. So if I want to do 2a, I'm going to multiply 2 times every entry in matrix A. Again, the result will be the same size as the original matrix. Here's my matrix. My nice 2 by 2 matrix. Matrix A, the 1-1 entry is 4. 2 times 4 is 8. It really is just a big distributive property. 2 times 1, 2 times negative 2, and 2 times negative 3. Well, if we can add and we can multiply, then we could do both at the same time. If I want to do something like 2c minus 3a, I can do that. A and c are the same size. Scalar multiples of them are the same size. We can add because they're the same size. Let's do 2c minus 3a. I'm going to do this in 2 parts. I'm going to do the 2c part and the 3a part and then add them together or subtract, whichever way you'd rather think about that. Here's 2c. 2 times everything in matrix C, negative 7 times 2, 12 times 2, 4 times 2, negative 5 times 2. You can either think of multiplying by negative 3 and adding, or multiplying by positive 3 and subtracting. I'm going to do that second thing. I'm going to multiply by positive 3 and then subtract. You can do whichever one makes more sense to you. So I want 3a, 3 times 4, 3 times 1, 3 times negative 2, and 3 times negative 3. And now I'm going to subtract carefully. I'm going to point out here that none of this is hard, really. It's all addition and multiplication, and those are things that you've known how to do for a really long time. But there's a lot of these operations, a lot of additions, a lot of multiplications, so there's just a multitude of opportunities to make a mistake. Just be meticulous and very careful as you go through, especially with signs. Here we go. I have negative 14 minus 12. 24 minus 3. 8 minus negative 6. There's a sign thing that I was talking about. 8 minus negative 6 is 8 plus 6. Negative 10 minus negative 9. And there's our results.